Hi, my name is Eduardo Ox. I'm the author of an MX package called EV, and a few weeks ago I gave a very bad presentation at the MXConf 2023 about an application of EV. The title of my presentation was REPLs in Strange Places, Lua, LaTeX, LPEG, LPEG-REX, and TICs. And the idea is that the presentation should have a way to let people try what I was showing, because the central idea of EV is that everything should be easy to try. Well, let me explain that in a better way. Let me start with a question. Why should people learn EV? Most people say that it looks like a kind of org mode, but uglier and less powerful. And let's look at these ideas here. Scripts made with org mode and code blocks, they look very professional. They can be exported to HTML and PDF easily. You can show to other people what you're doing. You can make blog posts. All the fontification happens in the right way. You have colors and so on. And scripts made with EV and EPeach, which is one of the best starting points for EV, they look very bare bones. They have some ideas that are the opposite of this must look professional, and they have some strange influences in their aesthetics. For example, they are influenced by the ideas of Peter Brook of how about rough theater, about using the least scenery possible, and so on. Whatever. So people have very good reasons for spending 10 years trying to learn org, and they have very good reasons for spending just a few minutes trying to learn EV. But the tutorials of EV are full of try-its, and one of the filters of EV is that some people who try the try-its look EV, but some people refuse to try the try-its. They just want to see explanations and a professional description of what this can do for them, how this can solve their problems, how this can earn them money, and so on. And they don't find that. They refuse to try the try-its, and they hate EV. Anyway, what I want to show in this short video is the try-its for my presentations on REPLs in Strange Places. These try-its only became ready several weeks after the presentation, and now I'm going to show rather quickly how to run them. This is the list of intros of EV. Let me switch to a smaller font here. The one that we are going to see is here in the section of advanced features that require extra setup, and the name of this intro is Find Show True Intro. Let me go straight to that intro. It's here. Here we have an introduction that explains very roughly what these things are. The main idea is that at some point the main attraction of this thing will be a tutorial on how to use LPEG, that is a tool for generating parsers. But this tutorial does not exist yet. Anyway, the focus here is on how to try this thing. You need to start here. This is not a very basic try-it. It has some prerequisites. It expects that people will understand most of these expressions here. And one of the most basic things is that when you type F8 on a line that starts with two red stars, the F8 treats that line as a comment and shows the content of that line in the echo area. When you type F8 on a line that has only one red star, the rest of the line is treated as Lisp. So these lines here that take a few seconds to run, they will assure that we have access to Melpa and that the package system is installed. Oops. Oh no, I need to fix something here. Whatever. I'll do that later. And then these other two sects here will guarantee that we have PDF tools installed. And this last one here, that is a comment, if we execute it with meta-e, then it will show the description of the package PDF tools. It will, in my case, it will show that that is installed and so on. Then to try the demo, people have to install some system-wide dependencies. I mean, this first block was for an Emacs-wide dependency, that is PDF tools. In my case, I need to run this block here because I'm running Debian. So I need to run this. In this case, if I send these lines to a shell with F8, it's going to show that all these packages are already installed. And then I have to give more F8s here, just to define links to some manuals. For example, now this link here, if I execute it with meta-e, it will open the manual of LPEG, a local copy of the manual of LPEG. Then we have to run this part here that installs some things in /tmp, and this first block here clears the directory in which I'm going to put most of the things, and it clones my programs, the ones that I showed in the presentation, in a very incomplete form. Then this other block here, they clone other two repositories of something very specific about Lua, some extensions to LPEG, and they compile one of these extensions that need to be compiled with GCC. And then we have to run this other block here that defines links to some manuals. For example, whatever. And then I have to run this block here because the communication with some of the external programs that will be run from Emacs will be done using environment variables. Then this block here is just a technical comment. And then here we have the first non-trivial test. These three lines here will create a target buffer running Lua here. And then I will check if my pretty printer works. It does. It's able to print associative tables in this format. And then I'm going to do some other things here. I'm going to inspect the path and then load an extension of my pretty printer and ask it to tell me the contents of the table of methods of my pretty printer. So for example, it prints the method getSorted KVS as this, and this thing is something that I can run in Emacs, and it shows the source code here in the window at the right. Let me close this and go back. This is a test that we need to run just to check if LPEG Rex is working. It's not very important. LPEG Rex is only going to be used in a very few tests, and just to compare LPEG Rex with my hacker-friendly version of its main functions. So here's the test. It adds some paths to the Lua path, and then we just need to check that these things here run without errors, but the output is boring, as I've said. This is another test that just checks if LPEG Rex can be loaded in another way. It's also boring. It only shows that some of the functions are defined. And this is the non-trivial part that shows the things that I've explained in my presentation. The first thing is that most of my tools use one of the windows to display a PDF, but the PDF must be regenerated by Lua, and we need to tell Lua where to put that PDF. And this is done by setting some environment variables. And the function that does that is called showToUse, that tells show2 which directory to use, and it works in a very non-trivial way. But usually we run show2 use before a block like this one. And remember that some parts of blocks like this are things that are not important. For example, if I run this, then it shows in the window at the right the current target. Sorry, this example. If I run just this, it shows in the window at the right a target buffer that may not be important. Then in the second line here, it kills the current target buffer, and then in this other line here, it recreates the target buffer so that I get a new target buffer running Lua. This line here that is whose logic is very non-trivial, it also uses the window at the right, but it uses the window at the right to explain what it is doing. So if I run this, it shows in the window at the right how its argument is going to be interpreted, how it's going to be processed to set some environment variables, and explains lots of things, including how it's going to define these functions here that set up a 3-window setting like this. But let me go back to this part of the demo here. If I run all these lines with F8, each one of the lines will show a buffer like this with the information about what show2 use does with each of these arguments. So I can just type several F8s here and compare how things change. So this is just a way to let people understand how this function works. And it uses a nice trick that I only invented a few weeks ago, that is using the window at the right for explaining the logic. And now here is a basic example of using show2 use and using show2. And this line here with the show, it takes a few seconds to run. It creates a PDF, and this line here creates the 3-window setting with the script being edited here, the E, the target buffer here, the T, and the viewing buffer here, the V. So this works, but it's very basic. There are some explanations here. This is an example that is slightly less trivial. We can first execute it like this. Note that here we have these 2 lines that look redundant. In the first, we define the global variable body in a certain way, and the second, we redefine body in another way. So let me run this again. Show 00 and show 0 are just debugging functions that show what is going to be saved in the tag file. And this last line here, will just show without any zeros, saves the tag file and produces the PDF. And it takes a few seconds to run. We need to wait until it finishes, and we need to check if its output says either success or error. And if we got a success, then we can run this, the ATV. And note that this option here has told show to include some things here that would scale the output. It includes this scale box for here. And then this part of the tutorial explains that we can run these lines here in any order, and we can now remember that in the first time this first line was ignored because the second one redefined body, but now we can run this first line here, and now this value is going to override the other one. Then we skip this hello without the backslash here. We run these lines again, and now the show is going to say that we didn't get a success, we get an error. So now the ETV would not work. It's going to show something spurious, and we can show the log of the compilation. It's going to see what went wrong. And we can also run this to examine what was saved in the tag file. So this was just a basic demo to explain how show-to works and how ETV work and how we can use these several variants of show to inspect what is being saved and compiled. And now we have a few less trivial tests, in the sense that these tests are going to show something in the PDF that is not so trivial. Here we get one test that is in a test block in this file. The file is called parse32.lua, and this line here goes to this test block. And if we run this block here in the test block, it uses a parser that is defined in this file. It parses this string here. It displays the abstract syntax tree generated by parsing this string. And then we have some other lines here that process the tree in several ways that I do not want to explain. But important is that at this point here, at this line, I take this object here produced by under bracifying 09, and I run the show method on it. It takes a few seconds. It says success. So now this is going to work, and it displays this parse tree here. So this was one of the non-trivial tests. Here is another one that the output looks trivial, but the logic is not. The test is this one. It produces this tag file here that loads several other tag files and the style file. They are all included in this directory here. Here you can see that is /tmp show2 lpag2 /latex. So it's a temporary thing, but it has lots of Lua files and some tag files. And this thing here is processed by one of the things that I use to generate diagrams in LaTeX is a package called deadnut6. And if I run this, it generates a PDF, and the PDF is this. So this thing is a variant of verbatim mode. And this is something that will be very interesting at some point, but at this point is not really interesting. This is my hacker-friendly version of LPAG Rex. And here are some examples of how it works. I tested either all or most of its test blocks, and they are working. For example, this one is a test block that defines the grammar that starts very basic, and then it's changed a bit at a time. And then we change the grammar, and we ask this function here to use the current grammar to parse this thing here, considering that this symbol here is the top level symbol of the grammar. So it shows how we can parse arithmetical expressions with the right precedence. And that's it. At some point, this thing is going to become a tutorial of LPAG, but at this moment, it is not. Anyway, so here we have lots of Lua files, and most of these Lua files have, let me see if I have something interesting here. Most of these Lua files have test blocks that you can run in your installation using in which everything is in the TMP directory. For example, this one. No, let me try the last test block in this file. there's some weird things here, but then it has a show. The show saves a tag file and compiles into a PDF, and then this thing here shows the result. That is something three-dimensional here and some other things here. So yeah, that's it. I hope that everything will be easy to run. I have only tested this thing on Debian, and I have one friend that is testing that on Mac OS, and another friend who is testing that on Arch Linux. And if you can test that on your system, then please get in touch. Please tell me if things are working. Please help me to debug these things. And yeah, that's it. That's it for the moment. Thanks. Bye.